In this video, I'll be covering the categories of general solutions, the types of general solutions you will encounter in your exams. So I've grouped them into three categories. And the first category is where you would require to simplify, do some simplification. You might be given double angles and compound angles, so you have to deal with them and kind of like work around how to getting everything into a single trig function, trig ratio. And then second is where you have to deal with a co-ratio, converting sine to cos or cos to tan using 90 degrees. And the third is where you have to use trig and it's given in quadratic fashion and you have to solve it so that you find your reference angle. So I'll be going through the three types, and I think grouping them mentally also helps you prepare for them better. So let's move into the first one. In the first one, we have a simplification type of general solution. And the question says determine the general solution of 2 plus 2 cos of 2x is equal to 0. So outright, we can see that we have something that's double angle of cos. So the double angle of cos, we always have three options of how to solve them. The first is 2 cos squared x minus 1, and in no order. Then second one is cos squared x minus sine squared x. And the last one is 1 minus 2 sine squared x. So you can choose any of the one there. We should get the same answer. So for simplicity, let's take the first one, where it's going to be 2 plus 2. Let's open the brackets. We're going to have 2 cos squared x minus 1. And we can go ahead and simplify this. Be 2, multiply the 2 in the brackets, and also in the minus 1. Then we're going to have 4 cos squared x minus 2 and equals to 0. What then happens, you can see that the 2 and the negative 2 cancel off, and we are left with 4 cos squared x is equals to 0. You divide everything by 4 so as to cancel the 4 on the left hand side. We are left with 2 cos squared x is equals to 0. Then if we apply the square root on the left hand side and the right hand side, we'll be left with cos x is equals to 0. So cos x is equals to 0, we're going to calculate our reference angle, which will be equals to the cos, second function of cos of 0, and this will give us second function of cos, give us 90 degrees. That's our reference angle. But don't forget, we still need to calculate our quadrants. Just as a quick reminder, for quadrants, we're going to use our cast diagram, where we know that the first quadrant, all the trig functions are positive. The second quadrant is where sine is positive. The third quadrant is where tan is positive. In the fourth quadrant, only cos is positive. The fourth quadrant is represented by 360 minus. Then the first quadrant is where we only write our reference angle. 360 minus your reference angle, I'll just say r. And the second quadrant is 180 degrees minus your reference angle. Then your third quadrant is 180 degrees plus your reference angles, and your angles there is 180, 90, 0, 360, and 270. That's a quick crash course on your cos diagram. So we reference the cos of x is equals to 0 where your trig function is equals to a number, right? Which means our 0 is positive, where is cos 0 in the first quadrant and in the fourth quadrant. So our main focal areas will be quadrant 1, where we're dealing with x. So x will be equals to the first quadrant reference angle, and we're dealing with cos, so it will be plus k times 360. So our first solution will be the reference angle we calculated here, 90 degrees, plus k times 360. And we can move on to the next quadrant. We said cos is positive in the first quadrant, then the fourth quadrant. So quadrant number 4. Quadrant number 4 will be dealing with x. So it will be x is equals to 360 minus the reference angle plus k times 360. X is equals to 360 minus the reference angle, which is 90, plus k times 360. Therefore, x is equals to 270 plus k times 360. And we know that we have to mention that k is an element of integers. And in that way, we would have gotten both our solutions, mentioned k, gotten our reference angle in 90 degrees. And then we would have answered our question. The interesting and tricky part is the solving and simplification before we get to our reference angle. So let's move on to the next type. We're still on the simplification, but it's a different question. So in this question, we're given that we need to solve for x if. So what do we do if that's the case? And you also, if you pay attention, you'll see that we're also given an interval. So what do we do when you're given such a situation? So we're given that 10 sine x plus 10 sine x plus 1 is equals to 110. And then we need to find the x values for which lies between negative 360 degrees and 360 degrees. So that's our interval that we need to find values for. So let's first find our trig ratio in standard form and then find our reference angle, and then we can pick it up from there. So if you can just remember from laws of exponents, remember that a to the power of n plus m can be written as a to the power of n times a to the power of m, meaning that we can reverse engineer this part here. What do I mean by that? If we have 10 to the power of sine of x plus 10 to the power of sine of x, can also be written times 10 to the power of 1, because this can give us the combination there at the top, which is equals to 110. So what we've done allows us to have a common factor of 10 to the power of sine of x. If we take out a 10 to the power of sine of x there, we're left with 1 plus 10 to the power of 1 is equals to 110. So 10 to the power of sine of x, 1 plus 10 gives us 11, is equals to 110. Divide both sides by 11. We get 10 to the power of sine of x is equals to 10 to the power of 1, because 11 goes 10 times into 110. So if we have the same bases equated, we know that laws of exponents allows us to say and equate the exponents. So now we can find our reference angle. Since sine is equals to 1, we just say our reference angle equals to arcsine, second function of sine of 1, and the second arcsine of 1 gives us 90 degrees. And since sine is equals to positive 1, it means in our quadrant, in our cost diagram, we will be working with first quadrant and the second quadrant where sine is positive is in this quadrant where it's 180 minus r, and the first quadrant where it's just a reference angle, because sine is positive in the first quadrant and the second quadrant. So we'll be dealing with quadrant 1. Quadrant 1, we know that we're dealing with x. The x is equals to our reference angle plus k times 360. Therefore, first solution will be 90 plus k times 360. And we move on to quadrant 2. Quadrant 2, we know that x will be equals to 180 minus reference angle plus k times 360, which will be 180 minus 90 degrees plus k times 360, which will be x is equals to 90 plus k 60. We know that k is an element of integers, and if you notice, the solutions are the same, right? But remember, we said we need to find x values that lie in between here, that interval. So how do we go about that? It's a very simple process of doing that. We know that our solution, x is equals to 90 degrees plus k times 360. 260 degrees. What we do, just simply construct a very basic and simple table. This table will allow us to find all those values. So let's quickly construct this table. Where we're going to substitute our values. And in this table, we're going to use usually 3 numbers always suffice. You don't really need to extend yourself. So it's -1, 0, and 1. So what happens, we're going to first substitute -1 where there's k there. If you substitute 1, if you substitute -1 where there's k, it's going to be 90 minus 360, which will give us negative 270 degrees. Then substitute 0 where there's k, which will be 90 plus 0, which will be 90 degrees. And then we're going to substitute 1 where there's k, which will be 90 plus 360, which will be 450 degrees. Remember the interval that's been given to us. The interval that we've been given is the interval of minus 360 until 360. So we need to find values that lie in between there. What are those values? X will be equals to, obviously, negative 270 lies in between this interval. Negative 270 degrees. And what else? X is equals to 450 is outside, so 90 lies inside. So our two solutions are x is equals to negative 270 and x is equals to 90 degrees. And that'll be it for simplification. Let's move on to the exercises that have a co-ratio, of which a lot of learners tend to struggle with. So I'll be breaking it down so as to simplify it. Consider the co-ratio type general solution. We were given the general solution of the sine of 2x is equals to the cos x minus 30 degrees. This is one of sections of general solution that a lot of learners tend to struggle with, but I'm sure after these examples you'll be able to really tackle these questions without no problems. So what we're going to go ahead and do, we have two options. Either we change the sine to look like a cos, or we change the cos to look like sine. So let's for once take the difficult road, where we're going to change the cos to look like the sine. So it will be sine 90 minus that whole angle, x minus 30. And notice that we have sine and sine, but let's further simplify that in brackets. So is to tighten it up a little bit more. It will be 90 minus x, because we're multiplying it by negative, and plus 30 degrees, which is in essence sine 2x is equals to the sine of 90 plus 30 is 120 degrees minus x. And now then we can find our reference angle. by equating 2x and 120 minus x, which will be 2x is equals to 120 minus x plus k times 360, and this will be for quadrant 1 because we're dealing with sine. Then for quadrant 2, it will be 2x equals 2, and we go to a reference angle, which will be 180 degrees minus 120 minus x plus k times 360. So we just need to solve both of them. Remember, we're solving for x. So we take the x, negative x, bring it to the right hand side, left hand side. It will be 2x plus x is equals to 120 plus k times 360, which will be 3x is equals to 120 plus k times 360. Divide everything by 3, it will be x is equals to 40 degrees plus k times 120, because everything is divided by 3. 120 divided by 3 will give you 40, 360 divided by 3 will give you 120. And we mentioned that k is an element of z, or integers. And our second solution will be 2x is equals to 180 minus negative multiplies outside 120 degrees plus x plus k times 360. And then we have to group the x's. There's 2x on this side and there's an x there. If we take this x, bring it this side, we'll have an x. On the left hand side, it will be 2 minus x, which is x. Then we have 180 minus 120, which will give us 60 degrees plus k times 360 degrees. And in that way, we would have found our two solutions. And we would have also gotten marks for all the work we did of converting the correlations. Let's move into the next one to further explore our knowledge on correlations. So here we're given the sine of 48 degrees times the cos of x minus the cos of 48 degrees times the sine of x equals to the cos of 2x. So something interesting is happening here. We have sine, cos, plus sine. This rings the compound angle sine, which says sine of A minus the sine of B. This will give us sine of A times the cos of B minus cos of A times the sine of B. So we are here. So we have to reverse engineer it to come back to there. So what we do, we just write it as sine. Our A in this instance is 48, and our B will be our x over there. So it will be 48 minus x is equals to cos of 2x. So in this instance, we can change this cos to look like the sine, which will be the easier approach this time. In the previous question, we took the more complicated route. So let's take the easy route here, where we're going to say sine will be 90 minus 2x. And now we can find our reference angle. Our reference angle will be 48 minus x is equals to 90 minus 2x. And this will be for quadrant 1. So we add plus k times 360. And since we're dealing with sine, quadrant 2 will be 48 minus x is equals to 180 minus 90 minus 2x plus k times 360. And we just simplify now. We take this negative 2 to the other side, we'll have negative x. 2x, we take the 48, bring it this side, we're going to have 90 minus 48, the k times 360 always remains on the right hand side. And then minus x plus 2, we have x. And then simply we have 90 minus 48, it will give us 42 plus k times 360. Then we move on to the next. For quadrant 2, we have 48 minus x, which is equals to 180 multiplied by the negative 90 plus 2x plus k times 360. We bring the x to the left hand side. We're going to have negative x minus 2. Bring the 48 to the right hand side. We're going to have 180 minus 90 minus 48 degrees plus k times 360. So let's make room for this solution. So let's pick it up. Let's bring this working to the top here. We will have negative x minus 2 to give us negative 3x. Is equals to 180 minus 90 minus 48 gives us 42 plus k times 360. Then we divide both sides by negative 3. Divide both sides by negative 3, we get negative 14 plus negative. Remember, we also divide the plus k times 360, which will be negative k, and then 360 divided by 3 will give us 120 degrees, where k is an element of C. And that will be our solutions, and obviously we get marks for the workings that we did. This next subtopic of trinomial quadratic type general solutions will really be working through general solutions that resemble quadratic equations, and I'll be taking you through them. Let's consider this example where we also determine the general solution of cos 2x minus 7 cos x minus 3 is equals to 0. So what stands out here is the double angle of cos. All right, I have a double angle of cos, and what we need to do is to change this double angle to one of the 3 options we have for cos. And these are the 3 options that we have for double angle of cos. And how do we know which options to choose? We already have cos in the equation, so we just take one, but really with only a cos to make things a bit lighter for us. So with this cos 2x, we're going to replace that with cos squared x minus 1. And then we continue with the original equation of cos of x minus 3 is equal to 0. And then now we group like terms, minus 1 and minus 3. So we'll have 2 cos squared x minus 7 cos x, and then minus 4, which is equal to 0. So now we have standard quadratic. If this doesn't look like quadratic, we can replace the cos x with x, which will be x squared minus 7x minus 4 equals to 0. Now it looks more like a quadratic equation. So what we do, we have to open 2 brackets. We have to find the factors of 2, and for that which we multiply gives us negative 7. That which we add or subtract gives us negative 7. That which we multiply gives us negative 4. So in the first quadrant, we're going to have cos of x. In the second bracket, we're going to have cos of x, because this gives us 2 cos squared x, and then the factors of 4 are 1 and 4. So I'm going to have 1 and 4. And since we are looking for, when we multiply them, we need to get a negative 4. We already know that one has to be positive, the other needs to be negative. But you can always try and error this step by multiplying out the brackets to see if your answer really does make sense or brings you back to this step. So now we equate this bracket to 0 and the second bracket to 0, which will be 2 cos x plus 1 is equal to 0, or cos of x minus 4 is equal to 0. So for a moment, let's erase that because we need more working space. So we'll bring it up. So we have to make cos x subject. So we'll have 2 cos of x is equal to minus 1 and cos of x is equal to negative 1 over 2. Or we're dealing with cos of x minus 4. We're making cos of x subject. It's cos of x is equal to 4. So now what we need to do is a critical stage where we have to find the reference angle. So it means we'll possibly have 2 reference angles. The first reference angle is cos second function of 4, and this is invalid, so it's not applicable, which alleviates us from getting 2 reference angles. And then on this end remember we have a negative here. This negative just tells us we're going to be working with quadrants where cos is negative, and cos is negative in quadrant 2 and quadrant 3. So refresher, remember your cost diagram where we have 90, 180, 270, 360, and 0. And we have 180 minus second quadrant, 180 plus third quadrant, 360 minus, and the first quadrant is the reference angle where it's called cost diagram. 180 minus our reference, 180 plus our reference, 360 minus our reference angle. So cos is negative in the second quadrant and third quadrant. So let's go back and calculate our reference angle. How do we calculate our reference angle? Simply say the cos second function, we don't include the negative, we only include the value of 1 over 2, and the cos of 1 over 2 is 60 degrees. In your calculator, you're going to just say shift cos 0.5, and it'll give you 60 degrees. So since we have our reference angle, let's use our quadrants. We're dealing with x. So we're going to have x is equals to, in the second quadrant, we said it's 180 degrees minus the reference angle plus k times 360. X will be equals to 180 degrees minus 60 plus k times 360. X is equals to 180 minus 60 is 120 degrees plus k times 360. In quadrant 3, we have x is equals to 180 plus the reference angle plus k times 360. X is equals to 180 plus our reference angle plus k times 360. 180 plus 60 will give us 240 degrees plus k times 360, where k is an element c, and we're going to get over our 4 marks. And for the workings, depending on the question, whether it's 4 marks or 5 marks or 6 marks, and that's how we break down a trinomial quadratic general solution type. Let's move on to another one for variety. So in this one, given that we need to find the general solution of 6x, 6 sine squared x plus 7 cos of x minus 3 is equals to 0. So we have a sine and a cos. So we can change the sine squared into a cos. by using the identity sine squared plus cos squared x equals to 1. If we make sine squared x subject, it's 1 minus cos squared x. So we can just put 1 minus cos squared x with the sine squared x. So it will be 6, 1 minus cos squared x plus 7 cos of x minus 3 is equals to 0. Then we multiply in bracket by 6. And I have 6 minus 6 cos squared x plus 7 cos of x minus 3 equals to 0. We have like terms, we have 6 and 3. So we're going to write negative cos squared x plus 7 cos of x, 6 minus 3 will give us 3 is equals to 0, and we can multiply everything by this negative. So we have cos squared x minus 7 cos of x minus 3 is equals to 0. Open two brackets, find the factors of 6 and 3, that which we add up to that will give us negative 7, that which we multiply will give us negative 3. We have the cos of x and 2 cos of x. Factors of 3 are 1 and 3, and when you multiply, the signs need to be negative, so it's positive and negative. And if you're struggling with this step, yeah, you can do it very, very slow and do it and use trial and error to get to your solutions by listing all the factors of 6 and all the factors 1. The factors of 6, which is 1, 2, 3, and 6, and the factors of 3, which is 1 and 3, and then we have to group them into 2s to see which of these factors will give me 6 when I multiply them. Automatically I can see that if I multiply 3 by 2, it will give me 6, and only have only one option for the factors of 3, which is 1 and 3. So what I then do, I have to cross multiply these numbers here. So when I multiply 3 and 3, I get 9. 2 and 1, I get 2. But what are the signs of these numbers that need to be to give me? Remember, when I add or subtract, I need to get negative 7. I know that this 9 needs to be negative. So negative 9 plus 2 will give me negative 7. So to achieve this negative 9, it means one of the values here I need to be negative 3. But negative 3 will give me negative 9. 2 pi 1 will give me 2. So what I then do, I take these values as they are. These will be my factors. As you can see, 3 corresponds to 1, and there's a positive sign since there's no sign there. It's 3 and positive 1, and positive 2 and negative 3, positive 2 and negative 3, and then you would have found the factors, and this is one of many ways of doing it. So let's continue. So we have 3 cos of x plus 1 is equal to 0. And this can be written as 3 cos of x is equal to negative 1. Cos of x is equal to negative 1 for 3, or for the other factor, 2 cos of x minus 3 is equal to 0. 2 cos of x is equal to 3. And the cos of x is equal to 3 over 2. So let's find our reference angles. So let's start with the reference angle on the right. Should be the cos negative 1 of 3 over 2. And this will give us really an error, which is not applicable. Then our reference angle here, remember we have a negative, and a negative simply means that we need to find quadrants where cos is negative. And the quadrants are quadrant 2, where cos is negative, and quadrant 3, where cos is negative. So the reference angle is the cos second function 1 over 3, which is equal to 70, 5 3 degrees. So it's in terms of x. Our first solution is x is equals to 180 degrees minus the reference angle plus k times 360. X is equals to 180 degrees minus 70,53 plus k times 360. So x will be equals to 180 minus 70,53, 109,47 plus k times 360 degrees. That will be our first solution. And the next solution will be x is equals to 180 degrees plus the reference angle plus k times 360. X is equals to 180 degrees plus 70,53 plus k times 360, where x is equals to 250,53 plus k times 360, where k is an element of z. And we've gotten our 4 marks and for our workings of reference angles and simplifying our quadratic general solution.